Si Mano palabyo, mahal magbaligya. Adobo, sitsaron, ukod na ang mantika. Parisan pa ug luyat nga taong si Mano palabyo, mahal lang gihapon. Tugtog. All right. This is our problem. Relax, baby. The, the figure shown below is composed of arc of circles with centers at each corner of the square, 20 cm by 20 cm. Find the area of the region common to the circular arcs. It is the shaded area in the figure. So this is the figure. We have this square. I will show my laser pointer. Okay, we have this square. And we have these four quarter circles. Okay, four quarter circles with centers at each corner. So the center of this quarter circle is this corner of the square. The center of this quarter circle is this corner. The center of this quarter circle is this corner, and so on. Of course, the last quarter circle, the center is this corner. Okay? The question here is, what is the area of the region bounded by these four quarter circles? It is the shaded region in the figure. This is also given, okay, in the problem. How to calculate this area? There are many ways to calculate this area, but in this problem, in this video, I am going to present 3 solutions to solve for this area. Number 1, okay, how to do that? We are going to consider this area. To find this area, we are going to consider the whole square. Okay, we are going to solve this whole square. That is 20 by 20. Minus this area, minus this area, minus this area, minus this area. I'm still laughing with my song in the intro, in the intro of this video. What remains if you are going to remove these 4 areas? What remains is the required area. Take note that these 4 areas are equal. Okay, so we are going to solve only one of these, one from these 4 areas. Okay, let us move this figure to the right for no reason. Just the part of the solution, we just move that to the right. Okay. Then let us concentrate solving our figure, this one area only. Okay, how to solve this area? Take note that we are going to multiply this area by 4 so that we can find this area here. How to solve for this area? Very easy. Let us find the area of this quarter circle that contains this area. So this 1/4 of the circle with center here. Okay, this quarter circle, remain that. Okay, let us find this area. What is this area? 1/4 of pi radius squared. Our radius is 20. Diba? 1/4 of the whole circle of radius 20. That is equal to 100 pi. And let us remove this sector of a circle. Now, the question is, we already know the radius of this sector of the circle. But how about the central angle here? What do you think is the central angle here? If you want to do that in trigo, you can drop a line here from this point up to that point. Take note that this is a midline. A midline of this square. Okay? Meaning, we will bisect this 20 cm into 2 equal segments. This will be 10 all over 20. Alright? That is actually cosine of 10 over 20, cosine of 1/2. A cosine of theta is equal to 1/2. Therefore, our cosine of 1/2 is 60 degrees. Or another way to do that without by inspection only is to understand that this point and this point, if you connect that, is also 20. Because from here to here is also radius of the circle, which is 20. Okay? From here to here is 20. Meaning, if this is 20, 20, 20, we have this equilateral triangle. So, we have this central angle dito. at this point, 60 degrees. All right. How to solve for the sector of the circle? Can you still remember the formula for the sector of the circle? With central angle theta in degrees. If you forget that formula, you can actually do Ratian proportion. I will write it here. By Ratian proportion 10. I will select a color. Yellow. We have this area of the sector as to central angle. Okay? Is equal to area of the whole circle. That is by proportion. Area of the whole circle as to central angle of the whole circle. The central angle of the whole circle, you can use 2 pi. If you are going to use 2 pi, your theta will be in radian. But our theta is in degrees, so we are going to use 360 degrees. That's why, if you are going to call this area, area 2, the sector of the circle, area 2, the area 2 is equal to pi r squared. You can see that. Okay? Laser pointer, pi r squared. This one, pi r squared, times the central angle, 60 degrees all over 360. So we have this area 2, 200 over 3 of pi. Then, after we remove this sector of the circle, what remains is these 2 areas. We are also going to remove this segment of a circle. So what is the area of the segment? Of course, if you are going to, the central angle of the segment of the circle, because this belongs to this arc of circle, is this corner. So meaning we are going to connect this point and this point to define the segment. Okay? We know that this is 20. Central angle 60. All right? So take note that this area and this area are equal. Meaning, to find this area, we are going to calculate the whole sector, or this sector. Okay? This sector minus this triangle. The same here. The same area here. This sector, which we already found, 200 over 3 pi, minus this triangle. All right? We can find this sector, which is equal to this, we can find this segment, which is equal to this segment of the circle. So let us call this area 3. That is equal to this sector, 200 over 3 pi, minus this triangle. What is the area of this triangle? 1/2 AB sine 60. Okay? 1/2 AB sine theta. 1/2 20 sine theta. So, theta is 60. Alright? That is our area 3, 36.234. So, what is this area? Let us call this area 4. Very clear that this area is equal to the area 1, the 1/4 of the circle, minus the quarter, the sector of the circle, we call that area 2, minus the segment of the circle, we call that area 3. We have this area 4. And take note that the required area is equal to the area of this square minus 4 times this area 4. Okay? This is the answer. Baby! This is our last part of our solution. That's it. That is how to solve that problem geometrically. And there is another way to solve that problem that will not involve this area that is not actually needed for the required area. That is not part of the required area. So we are going to do another solution. Let's go to that solution. We are going to, for this solution, we're going to divide this area into 4 equal areas. Like this one. And we're going to, because these 4 equal areas, because these areas are equal, these 4 areas are equal, we are going to solve only one of these areas. So let us say we are going to solve this one. Okay? After we solve this one times 4, that is the answer. Now, how to solve this one? Let us enlarge this figure for no reason then. For no reason also. We have this enlarged figure. Let's solve this area. Take note that some student will interpret this as a sector of the circle, but this is not actually a sector of a circle. Sir, that is a sector of a circle. No. Because when we say sector of a circle, it will contain the center of the circle. So this is not the center of the circle. This is actually of this arc. Okay? This is actually the center of the square. The center of this arc is this one. Okay? So for this to solve this for us to solve this area, let us first define the whole sector. Okay? This is the whole sector. If we can find the area of this whole sector minus this area here, we can find this area. That is actually this area already. Okay? So how to solve this sector of the circle? We need to know what is the central angle because we already have this radius of the circle. So what is the central angle of this sector? Let us call that central angle 2 theta. Let us first connect this point and this point. Take note that this is the center of the square, and let us call the distance, the length of this line, x. Okay? Now, the central angle, the total central angle of our sector, let us call that 2 theta. By the way, by Pythagorean theorem, we can find the x. Okay? We already have it here. By Pythagorean theorem, this is actually at the center of the square, meaning this is 10, because this is at the center of the square. This is 10, and this is also 10. So x is equal to, by Pythagorean theorem, x squared is equal to 10 squared plus 10 squared. Excuse me, therefore x is equal to 10 square root of 2 centimeters. All right? Again, I already said that we are going to call this total central angle 2 theta. Okay? For the sector of the circle. Now, what is the value of theta? We know that this is a 45-degree triangle, a 45-degree line. Because this is, actually, if we are going to prolong this x, it will pass to this point, which means that this is a diagonal of a square. We know that the diagonal of the square is a 45-degree line. Or by inspection, by inspection, we can understand that this is a 45-degree line, this x. Okay? How about this angle here? Let's call that alpha. If we can find alpha, we can determine the value of theta. From the figure, from here to here, because this is a midline of the square, is 10. This is 10. Okay? So opposite 10 over the hypotenuse 20, that is sine of alpha. Sine of alpha is 10 all over 20. Arc sine of 1/2, arc sine of 10 over 20 is, that is the alpha, 30 degrees. Okay? We already have the value of alpha. Therefore, the theta is 15 degrees. So the 2 theta here is actually 30. We actually trisect this right angle here. 30, 30, 30. Right? We now have the value of the central angle and the angle also of these two triangles. We can solve for this whole figure minus this triangle times 2. That is the area that we are going to calculate. Alright? So what is the area of the sector? Again, the formula is what? I'll write it again. If you forget the formula, you can do ratio and proportion. Area of the sector of the circle as to the central angle. Let us call that central angle phi because we have this 2 theta here. Is equal to area of the whole circle, pi r squared, as to 360 degrees if our phi is in degree. Of course, from our figure, our phi is equal to 2 theta. Okay? Which is equal to 30 degrees. Alright, so this is the area of the sector. The area of the sector of the circle, laser pointer, okay? Pi r squared, this one, all over 360, times 2 theta, that is equal to 30 degrees. Okay, 100 over 3 pi square cm. Minus this triangle. What is the area of this triangle? 1/2 AB sine theta. 1/2 20 times x sine theta. We already have the value of x. And that is 10 square root of 2. So 1/2 times 20 times 10 square root of 2 sine of 15 degrees. This is the area of the triangle. This area, which we are going to calculate, is equal to the sector, we call that area S, minus twice this triangle and this triangle, minus 2 times the area of the triangle. We can find this area only. 4 times this area, and that is the required region. That is the answer, baby. All right. That is the second solution. Let us proceed to the last solution for this problem. Totally, I like this solution. If you can see my previous video about that spherical frustum, the best way solution for me, that is my perspective, is the integration also. And also for this problem, I like the integration, solution by integration. Okay, how to do that? We are going to superimpose the xy plane, and just select your arc, and then locate your origin of the xy plane to the center of the arc. Okay, so we are going to divide this area into 4 equal. I will choose this arc. Okay, I will choose this arc. So the center of this arc is this one. So I will make this as my origin of the xy plane. Okay, so we can define now this arc of the circle. What is the equation of this arc of the circle? From analytic geometry, this is actually x squared plus y squared is equal to radius squared, which is 20, the sides of the square. That is the equation of this arc of the circle. All right. Then we are going to divide this area into 4 equal areas like what we did in the previous solution. Then we are going to consider one of these 4 areas. Of course, we are going to consider the area that belongs to this arc. Okay? That will contain this arc, which means that we are going to use this area. Okay? After finding this area, times 4, that is the answer. All right? So, in integration, the beauty of integration is we can reduce this complicated area into very simple rectangle. Okay? This area can be reduced into a strip where we are going to analyze only this strip. This is a rectangle. So we know the area of the rectangle, y times length times the thickness dx. It's the rectangle. We will just sum up these rectangles. We're going to sweep this area by this differential element from this point up to this point. Or all right, from left to right. So the equivalent of summation is actually integral for differential element. Because our differential element is dx, we are going to pick up limits from x1 to x2. All right? Times, what is x1 from the figure? The x1, of course, is this point. We'll start at this line. Okay, at this distance. That is the x1. Actually, that is 10. This is a midline of the square. Up to this point, this is the x2. We are going to define that later. Okay? x1 and x2. And we're going to multiply this one area. After sweeping that from x1 to x2, we are going to multiply this one area into 4. That is our whole equation. Then, we are going to define the length of this strip, the length of this y. If you can see from the figure, this is actually the difference between the upper end, okay, the upper end of the strip, measured from the x-axis, the upper end, minus the lower end of the strip. Okay? Meaning the value of y here is y upper minus y lower times the thickness dx. Again, our equation is in terms of x. So we need to express, in terms of dx, so we need to express y upper and y lower in terms of x. Okay? How to do that? Of course, from the figure, the upper end of the strip happened to lie on this circle with this equation, which means that the upper end of the strip is governed by this equation. This is the y upper, the upper end of the strip. That is the upper end of the strip. Square root of 20 squared minus x squared. Just solve for y in here. This is it. Okay? How about the y lower? The lower end of this strip lies on this line. This is a midline of this square, 20 by 20, which means the height of this line from the x-axis is always 10, no matter where this lower end of the strip from here to here. That is always 10. Okay? How about the x1? I already mentioned that. That is also equal to 10. How about this x2? Okay, this point. How about that x2? The distance from the y-axis to that point. What is the value of that? Of course, because this is 20, from here to here is 20, and from here to here is 10, this value of x2 is equal to what? Pythagorean theorem. Hypotenuse squared. I will not draw that. Okay? 20 squared minus 10 squared is square root of that. Okay? Hypotenuse squared minus 10 squared. From this triangle, I will imagine we have this line that will connect this corner, the origin, to this arc of the circle. That is 20. This is the 20 squared. Hypotenuse of this triangle. Okay? So this is 10 minus 10. So you get that x2. Substitute for our equation. It's 10 square root of 3. Substitute. Okay? Area is equal to 4 times from x1 to x2. Okay? To x2. From x1 to x2. Okay? Times y upper. Integral of y upper. Y upper. This is the y upper. The upper end of the strip. Minus y lower. Okay? Minus y lower. Y lower is 10. dx. Calcu. Boom. Very convenient. Provided you have a calculator capable of integration, because if your professor will require you to integrate that manually, do not use this one. But if you're confident with your integration skill, there's no problem for that. But if not, or for practical reason, do the other methods mentioned in the previous solution. Okay, not this one, but board examinations, we are allowed to use a calculator with with integral function, then we can use this more convenient approach. And this is my preferred approach personally. All right. Bye-bye.